A series of giant pelicans, long-necked turtles, and young crocodiles were found along the dried-out mudflats in the northern part of the Australian continent. The cause of death was not a virus, and it was not toxic chemicals either. Dissection of the respiratory tract of every animal revealed an astonishing detail. The windpipes of these apex predators had all been severely damaged from the inside. The culprit was stuck right in their esophagus. A creature less than 25 centimeters long, covered in hard scales and carrying a system of razor-sharp spines. A tiny fish species had decided to defy the laws of nature, crawl up onto dry land on its own, seek out predators, and turn their bodies into a deadly biological trap. An ecosystem millions of years old is collapsing. Scientists are completely powerless. And this is the brutal chain of truths about an ecological threat crawling up from beneath the mud. The moment a giant pelican or a freshwater crocodile opens its jaws and swallows this fish whole, it has no idea that it has just triggered an extreme defense mechanism. Anabas testudinius, or the climbing perch, is not a meal. It is a biological machine built for destruction. Instead of struggling hopelessly to escape like ordinary species, the instant it is trapped inside the predator's mouth, every muscle in this fish immediately locks rigid. Its dorsal fin, sharp as a spearhead, snaps upright, but the truly fatal weapon lies on both sides of its head. Two solid, bony gill covers flare open to their maximum width. Along the edge of the gill covers is not soft tissue, but a series of razor-sharp spines, curved backward. This entire structure works exactly like a reverse-hooked anchor. When the fish is pushed down into the esophagus, the gill covers spread wide and stab deep into the delicate tissue of the airway. The predator instantly falls into panic. It cannot swallow the object down into the stomach, and it cannot vomit it back out either. The more the victim thrashes, the more the bony spines tear tissue and clamp tighter into the blood vessels. Two severe scenarios unfold immediately after that. The row of spines completely punctures the windpipe, sending the great hunting machine into acute respiratory failure in only a few minutes. Or worse, the fish remains permanently wedged there, blocking the digestive tract, forcing the predator to endure severe internal tissue damage and complete exhaustion over many weeks. Any predatory creature, from birds and reptiles to mammals, needs only to open its mouth and swallow this fish to place itself in mortal danger. It completely shatters the greatest law of survival in nature. The prey does not run away, but turns its own body into a weapon to bring down the hunter. A fish species taking down a few predators right in its own swamp would already be an unusual ecological event. But scientists did not issue a red alert because of the animals that died underwater. The real nightmare appeared when people measured the distance from these dead creatures to the shore of the lake. This species was not waiting for its enemies to come into the water. It had planted its fins into the ground, climbed onto dry land, and begun walking across the continent. Fish belong in water. That is an undeniable physical law of biology. A fish's airway and gills are designed to extract oxygen from water flowing through them. Once out of the water, the gill filaments collapse, stick together, and the fish stops breathing within minutes. However, the climbing perch possesses an anatomical structure that challenges every ordinary principle. Hidden deep behind its skull is an organ called the labyrinth organ. This is a network of complex tissue folds containing a dense system of blood capillaries, functioning much like a primitive lung. This organ allows the fish to absorb oxygen directly from the atmosphere. Instead of suffocating on shore, it can survive on completely dry land for many weeks at a time. It has no legs, but it does not slither like a snake. The climbing perch uses its own spiny gill covers as support points, driving them firmly into the hard ground. By tensing its body and using an explosive flick from its tail fin, the fish lifts itself and launches forward. This marching process usually happens at night or in the dim hours of dawn, when fog helps its scales retain moisture. But the endurance of this creature does not stop there. Consider its survival mechanism when it faces the harshest conditions nature can deliver. When the burning summer dries out the swamps and evaporates the entire water supply, native aquatic species die off in massive numbers, but the climbing perch does not. It uses its tail and pectoral fins to dig down into the bottom layer of mud. There, it curls into a tight ball, secretes a special layer of mucus that wraps around its whole body to prevent water loss, and enters a state of summer dormancy. Its heartbeat drops to the absolute minimum. Its metabolism nearly freezes completely. It can lie motionless in cracked earth, dry as stone, for 6 straight months. The moment the first raindrops of the wet season hit the ground, the mud softens. Millions of fish break out of their protective coating all at once and rise to the surface like an invincible army, continuing their march to expand territory and dominate the ecosystem. A perfect survival machine on land. However, the Australian continent is surrounded by thousands of kilometers of salty ocean. A fish species that lives strictly in fresh water could never swim across this biological barrier on its own. So how did it appear at the gateway to Australia's waters? The answer reveals one of the worst loopholes in the human trade system. The original homeland of the climbing perch lies in the wetlands of Southeast Asia. However, over nearly half a century, it has carried out a silent and powerful march toward the south. It swept across the island networks of Indonesia, invaded the freshwater ecosystems of Papua New Guinea, and has now established a base in the Torres Strait, a chain of forward islands only a few kilometers from the northern coast of Australia. This expansion is not simply a natural migration, but the result of taking full advantage of loopholes in global trade activity. It uses a strategy of clinging to the perfect means of transport, exploiting human greed and carelessness to the fullest. The climbing perch possesses extremely flexible tolerance to salinity. It can survive in brackish areas where rivers flow into the sea. In particular, its ability to regulate osmotic pressure allows it to survive in muddy water collected at the bottom of fishing boats, or even inside ballast water tanks on massive cargo vessels. Thrown into dark, dry, and sweltering ship compartments, instead of panicking and ceasing respiration like marine fish species, it immediately activates a defensive survival mechanism, lowering its heart rate to nearly zero, stopping gill movement, and falling into a state of physiological stasis. When the ship reaches port, these fish, which look as if they have dried to death, are thrown out with waste by the docks. For any other fish species, that would be the end. But for the climbing perch, that is the moment the real invasion begins. That is the fatal mistake. The instant its scales sense the moisture of mud, the labyrinth organ restarts. The heartbeat returns. The fish springs back to life and crawls straight into the freshwater river systems of the new region. Constant human fishing and transport activity has unintentionally created an accidental delivery chain, providing free sea-crossing transport for an invasive species that cannot be stopped. A few strange fish arriving at port may not sound like the end of the world, but nature operates according to a closed and unforgiving mathematical formula. When you remove the top brick of the pyramid, the entire ecosystem collapses in a chain reaction that humans cannot control. To understand the scale of the disaster, we must look deep into the core mechanism of the food chain. Apex predators serve as ecological regulation machines. Their daily diet keeps the populations of herbivores, insects, and rodents from exploding. When this spiny fish invades, it severely reduces local birds, reptiles, and mammals. Once the controllers disappear, the event of ecological reversal officially begins. With no more birds left to hunt them, the numbers of insects, grasshoppers, rats, and disease-carrying rodents explode at an exponential rate. The latest ecological security damage reports point to an alarming reality. Harmful species are destroying as much as 40% of global agricultural output. Insects alone wipe out value reaching $70 billion every year. The Australian continent is one of the largest agricultural belts on Earth. If the natural food chain is broken, pest disasters will sweep across all crops, pushing food security into a severe crisis. Science does not need to predict this. because history has already recorded a similar sentence against human carelessness in underestimating invasive species. In the final stage of the Second World War, a species of brown tree snake slipped into the landing gear and cargo compartments of military aircraft, accidentally invading the island of Guam in the Pacific Ocean. This paradise island had absolutely no natural predator capable of threatening the snake. The result? The brown tree snake multiplied at rocket speed. It attacked and completely wiped out 10 of the island's 12 native forest bird species. With no birds left to spread seeds, the island's native plant communities stopped regenerating and slowly died off. Millions of snakes slithered onto high-voltage power poles, causing thousands of widespread electrical short circuits and paralyzing the island's entire economy, healthcare system, and military operations for many years. The fish now approaching Australian waters carries a more subtle and more comprehensive destructive force than the snake on Guam. It not only physically kills predator species, but also paralyzes the recovery ability of wetlands, creating an ecological void in which only the invasive species can survive. Realizing that the ecological threat was counting down, the government poured all its strength into intervention. Millions of US dollars were spent on containment campaigns, but what scientists got in return was nothing less than a challenge beyond control. National environmental protection agencies are trying to establish defensive barriers on the forward islands. However, every traditional ecological solution has been completely neutralized by the adaptability of this survival machine. Solution 1. Pour fish-killing chemicals into the water. This is a method that destroys the entire food chain across a wide area. The chemicals would wipe out native fish species of enormous economic value, such as barramundi and Murray cod, long before they could even penetrate the hard scales of the climbing perch. This species can even detect chemicals by scent and actively move onto land to wait until the poison becomes diluted. Solution 2. Use electric nets or high-intensity harvesting systems. The reproductive speed of this fish challenges every physical effort. A single female can lay tens of thousands of eggs in one short breeding cycle. Spreading nets through mangrove swamps, tangled with massive roots, is no different from trying to stop a storm with bare hands. The trap systems become overloaded after only a few nights. Solution 3. Introduce another invasive predator to kill them. This is the most classic and the worst mistake in the history of ecology that humans have ever repeated. You bring a new enemy into the environment, hoping it will consume the climbing perch. But nature always chooses the easiest path. The new predator will immediately ignore the fish with dozens of razor-sharp spines that can tear open its throat, and instead turn to attack gentle native species that are easier to catch. You cannot put out a fire by making its cause even worse. Every technical escape route has reached a dead end. On the final front line, the authorities have been forced to shift to the most primitive but most urgent measure, turning every citizen into the last line of defense. Public communication campaigns are now focused on one single message: neutralize immediately. Citizens are being instructed to kill every climbing perch they catch, preventing them from activating the labyrinth organ and re-entering the environment. Ecological quarantine teams are searching every puddle of standing water inside ship compartments and inspecting every piece of waterlogged equipment. The war is no longer confined to sterile laboratories. It has become a true broad-scale campaign to protect the ecosystem, carried out by the entire population. Across hundreds of millions of years of evolution, the boundaries between continents were strictly guarded by the vast walls of nature itself, the immensity of the oceans, steep mountain ranges, and extreme climate conditions. Rivers flowed within closed systems, predators refined highly specialized skills, and every living thing was confined to its own ecological region. But trade networks, maritime transport, and carelessness in human activity have torn apart all of those borders. We have unintentionally turned Earth into an open biological laboratory, where every variable lies beyond control. Taking a creature from one swamp and placing it in the core of another ecosystem is creating severe ruptures, destroying a balance that took millions of years to build. The collapse of a biological era does not always begin with supervolcanoes erupting or disasters from outer space. It begins when we allow a tiny fish to break rules that have existed for millions of years, until one day we suddenly realize that the natural world we once knew has completely disappeared after those crawling steps across the mud. The climbing perch is not only an invasive species, it is a harsh warning about the fragility of ecological balance. If we cannot control these tiny creatures, then humans themselves will be the next species forced to face elimination in a system that we have unintentionally broken.